In any case, this is the containers track, so welcome. This is the first one, so it's containers in AWS, the State of the Union. This will probably be the least in-depth technically today, so we're going to talk at a higher level about a bunch of different stuff, and then we'll dig in on the different services at a higher level later on today. So if you're looking for the deep dives, that'll be after this, and this will be a little bit more broad. So what's the difference between some of these container services? What are we looking at from a high level? Something like that. I'll leave time for questions at the end also. So if you have a question, just save it to the end. And if you don't want to ask your question out loud on the recording, so this is being recorded, Paul and I will take questions around the room after this as well. So to get started, so kind of the story of containers on AWS. So we have a couple different container options at this point. So why do we have more than one? So why do you need more than one orchestration tool? The whole story kind of started in 2014. So we've had customers running containers on AWS themselves, so from the very beginning. So that would have been, in most cases, Docker on EC2. So they ran it themselves, the same story that you get from a lot of people with Kubernetes right now. So they installed it, they ran it themselves, they built and shipped their own containers, and they did all of those management pieces themselves. And that was fine. But what we were hearing from customers is that this was kind of a lot of work. So there's a lot of little bits and pieces that go into moving all these containers, right? I have to figure out how to monitor. I have to figure out how to log. I have to figure out how I'm going to do my deployments. I have to figure out how I'm going to scale. I have to build all these containers. And customers said, okay, well, these are pain points, and we don't really like doing it. We'll do it, and it works, and we're really happy with the result, and we're happy with the tools that we're using. But is there any way that we can not do this ourselves? So we built ECS. So when it launched, it was called EC2 Container Service. It's now Elastic Container Service, but the story is the same, right? So a managed way of solving all of those pain points. So it lets you deploy, manage, and scale the Docker containers that you're running on your AWS hosts. So the big ones there, how do I manage the cluster itself? So the underlying pool of compute resources. How do I container orchestration? So how do I schedule and manage the containers across those hosts? And then the third piece is kind of the AWS piece, and that's how can I get closer integration with the other AWS services that I wanted to use? So I did kind of the move over from stuff that I was managing myself to ECS a couple of years ago, from the customer side and not the AWS side. And the last one was why I ended up doing it. It was how can I use the AWS pieces that I'm really familiar with? So EC2 auto-scaling groups, Route 53, stuff like that. How can I keep all of those pieces and then also add the new element, which was the containerized, the Docker piece? How can I have those both of those things at the same time? And a bunch of people were using ECS now to manage their production workloads. So this is Segment. They're a marketing data startup. They run the majority of their services on ECS. And my computer really wants to be on the Amazon VPN, and it does not work here. Okay, so this is Segment, majority of their services on ECS. So they process a ton of events in order to run their platform. So that's 160 billion analytics events a month, which is up to 270,000 a second. And they do this on top of ECS, where they can use auto-scaling to burst up to thousands of containers to handle all of those requests. And I think you see, probably from me also, but you see a lot of architectures that are either event processing, which is what we just talked about, or kind of the three-tier web app. So how can I start and run a server, basically? So maybe I'm using my own application code behind Nginx, so something like that. And you see a lot of reference architectures that show something like that. But Segment's not just using it for event processing, they're using it for ETL jobs, so extract, transform, and load. So how do I pull data from places like Postgres or a data warehouse, perform some operation on it? So I cleaned it up, I added another attribute for it, and then I loaded it somewhere else. So in this case, they're pulling their data from their customer clients. They're running processing jobs in ECS, and then they're loading it into Redshift, where presumably they can pull that data out of Redshift to perform some other operation on it. So what people have found is that they can use containers for not just kind of the traditional way of running things. So not just for web apps or for processing a bunch of events, but they could use it to have more flexible architectures that fit other use cases too. So for them, it was how can we pull data from lots of different places, do something with it, and then put it back somewhere else where we can read it somewhere else. And we talk about ECS a lot, but what people were saying, ECS was not the only way to run containers in production. So more people were running Kubernetes just on AWS than they were anywhere else, which is really similar, right, to the story of how people kind of started using containers on AWS themselves the first time. They were just installing and running Docker themselves. They were building and shipping their own containers. And then you had the same thing with Kubernetes. So they weren't just using Docker. They realized that they needed an orchestration platform. They had a reason that they weren't using ECS. They wanted to use Kubernetes. So this is Monzo. It's a financial tech startup that's based in the UK. I don't know if they're here or not yet. They're not in the US. I think I've sent them a million emails. I really want them to come. But so they're a Kubernetes shop, 350-ish microservices. It's just Kubernetes and EC2. So just like Docker originally, they installed it and they installed and ran Kubernetes themselves. And we'll talk about this in a little bit, but obviously with money, it's maybe more important than other things that I can get to my money all the time. So if I'm maybe a messaging app, it's okay if I'm not always highly available. But if I want to be able to use a debit card or a credit card, I should really hope that I have high availability all the time. So if I need to pay for something, I probably can't be waiting for like bank plan downtime. So they have high availability with Kubernetes at every level. So multi-master, hundreds of workers, all backed by highly available etcd. You have to be secure, though, with banking also. So they're using something called Direct Connect to peer in between third-party places, so like a payment processor, back to their resources in their AWS VPC. And this is a quote that's been passed around a lot. But Monzo said, deploying Kubernetes in a highly available configuration on AWS is not for the faint of heart and requires you to get familiar with its internals, but we are very pleased with the result. And that pretty much sums up not only running Kubernetes on AWS yourself, but also the same problems that people had just running Docker on EC2 themselves. So that we really like the results. We really like what this tool does for us, but being able to manage it ourselves is not something that we want to do. And I've had maybe more people than I can count say, so I need something that's in Kubernetes, but the prospect of having to operate this myself is really daunting. And the key here is highly available. So I can install and run Kubernetes with a demo app in a weekend and write a Medium post about it, and it'll be easy. It's easy to install, it's easy to set up, and where it becomes really difficult is highly available Kubernetes. So what happens if I lose a master? What happens if I lose a node? How do I recover? How do I deal with failure? Highly available Kubernetes is really difficult. This is a pretty common phase with highly available Kubernetes. So what people really want is run Kubernetes for me. So I want to use it. There's something that I want. It's a community that I'm interested in. Kubernetes has a great community, by the way. So tons of people contributing tooling, tons of people contributing resources. They're talking about it. They're sharing architectures. It's a great community, but not everyone has the ability to run it themselves. So we built EKS. So this was a reInvent announcement. So from just a couple of months ago. And what is EKS? It's managed Kubernetes. So manage and upstream. So the same kind of native AWS integration that we're talking about with ECS. And then upstream means we contribute back to the Kubernetes community. So if we change something so that it works with AWS, we contribute it back. It wants to be on the VPN. I will not be on the VPN. Cool. So it's the same thing now, right? So you have two different container orchestration tools, both kind of solving the same kinds of problems, right? I want to run containers. I like what they do for me, but I don't want to manage all those pieces that kind of go into just into operating them. So there's a theme here that I think has been kind of passed on from 2014, right? And we're in 2018. So it's run my containers for me. So I want to do them, I want to use them, I want to build with them. I don't actually want to run them myself. And that's really common. They're great, but there's a lot of work that goes into them. Which brings us to Fargate. Fargate, not a service, underlying technology for container management. So running something in Fargate mode means I'm not managing that underlying cluster infrastructure, so I don't have to manage or scale or give my cluster resources anymore. I handle everything at the container level, and then so I can scale pretty seamlessly in response to that. And I think it's a big change, but it's not really an unexpected change. So I think where you've seen kind of these orchestration tools going is and we'll look at this in a little bit more depth later, but you started off with kind of your first primitive, right, which was an EC2 box. So I had a server, I managed security groups for that server, I had IAM roles for that server now, I had a load balancer that I registered with the different servers, and that was kind of like my unit of work. So I might be running a different application on that server, but ultimately my unit of work was that server, that EC2 box. And what we've been seeing is we've been watching that unit of compute, that primitive, change a little bit. So things are at the container level or the task level instead, which means that if I want to run a container or a job and it's optimized for the task, I don't have to manage, especially with Fargate, I don't have to manage that backing infrastructure in order to run my application, which doesn't really care about the infrastructure. So part of being in a container is that I've added hopefully almost all of my configuration is inside that container itself. So why should I have to manage an EC2 instance in order to run something that has all of its own container in a box? And that's why I wrote it like that. So Fargate means not worrying about a lot of those things. So scaling, service meshes, the underlying infrastructure, your resources, your setup, all of that stuff, it's still there, obviously. So I think the most common thing I get tweeted is something serverless. And someone will be, did you know that serverless still has servers? And I did, in fact. I did know that serverless still has servers. But you're not the one running those servers. You're not the one that's patching, that's upgrading, that's installing new things. Yes, there are servers that are still there. I mean, it's like saying that there's no data centers anymore because you don't have your own data center. There are definitely still data centers, just like there are definitely still servers. But the point is that you can focus on what's really important for your application then, which is how can I make things run for my actual use case? How can I make things good for my customers for what the job that I'm actually trying to do, and less on am I using the right version of Ubuntu on this box. So Fargate passed it a task definition now, or a Kubernetes pod sometime in 2018, give it some resource limits, and then that's it. So in practice, what that looks like is that you end up with two separate launch types, and this is just a console screenshot, but you end up with kind of two different paths for the type that you want to run your container as. You have type EC2, which is the traditional one where you have access to your underlying cluster resources, or you have type Fargate, which means all you care about is that task definition and then nothing else. And then, again, this lets you kind of focus on what your actual workload is. So the job that you're running, the container that you built the task definition for, the function that you're running, that's it. You just focus on that, you define just that, and then everything else happens for you in the background. So this is what I was kind of talking about earlier, but how we think about compute has changed a little bit. So you've gone from these building blocks of EC2 instances, and how that meant kind of, and the way that people have been structuring their app has been changing a little bit too, right? Because you started off, and then, so maybe 2 years ago, everyone started doing the monolith to microservices thing. So I had my regular app, and I scaled up my app by starting a new service or by giving more capacity to a queue, but I worked with just my app. And And then you saw people rewriting them and saying, well, I don't want just one app anymore. Now I want to do microservices. So I can scale all of these pieces of my infrastructure independently. So if I have a messaging service, a queue service, and a UI service, I can scale my messaging service and not my other pieces. So you kind of saw how the applications were changing. And then that let us have some more flexibility, right? So I could scale these pieces independently. I could develop on them independently. I could deploy them independently. And then you saw the infrastructure changing kind of to reflect that. So if I have a cluster now in ECS, I deploy everything in my tasks. So I can scale up one task, one service, and not the other one or something like that. So you're seeing kind of not only the application change, but then you're seeing the infrastructure change too. So first, we want to have our containers as one of our fundamental primitives. VPN again. The recording will just be full of me not getting on the VPN. And you saw that when ECS first came out, so when people first started using it, so I was a beta user, so three years ago, I guess 4 years ago now, it still felt very much like regular EC2. So I could run things in my containers and my task definitions, but I still had to do a lot of things at the EC2 level, so at the server level. I still had to add an auto-scaling group. At the point where I started working with ECS originally, I had to have a Lambda function to scale up my at the container level also, right? Because there was no concept in ECS for how can I scale something just at the task level, just at the service level, just the same EC2 level. And then you've seen adding more things that supported it at just the container level. So not only now can I scale at the container level, at my cluster level, but I can also scale at the task level, so the service level. So you've seen things going down and down and down so that containers were kind of a fundamental primitive as well. So I can scale at the container level. I can do I can control security groups that way. I can do IAM roles that way. I can do everything at kind of the service container level when previously it was just at the EC2 level. And now I see that going down another step as well. So treat tasks as a compute primitive as well. So that's things like IAM roles for a task, auto scaling at the task level, load balancing among copies of a task, and then task level networking. And that stuff is important, right? Because as we're moving to these microservices, each microservice has different requirements. So if I have two different services, I have an order service and a messaging service, why should they both have access to the same resources? They're not doing the same job. So if I do one job, and the same for people, if I do one job and Paul does a second job, we're probably not on the same email list. We probably don't sit in the same office. We probably don't have access to the same resources. So if you have two services and they're doing two jobs, so they're multiple tasks, shouldn't they maybe have access to different things as well? So I should be able to load balance my traffic between my tasks or do an IAM role, so access at the task level or security at the task level as well. So what that really means for you is only kind of, it really just means supporting your workload at a better level. So you have all these options. So you can still run things at the EC2 level, and there are still lots of people that are running them at the EC2 level. But for those of us that are working with containers, it just means that we're getting more options. So let me control very granularly everything at the task level. So my permissions, my security, my access, my resources. Let me do all of that, which lets me fine tune it a little bit. It lets me optimize it a little bit. Lets me get more out of my resources than I would before. So I think Segment's a good example because they've packed thousands of containers on those hosts. And a lot of them are very short-lived. A lot of them are very small, but they don't need anything else than that. They can just power through them as often as they need to, and then they can pack as many of them as they can. And we'll talk a little bit about the placement strategies later and some of the deep dives. But when I was using kind of my monolith before, so running one copy of my application per host, that was kind of it. That was the end of the road, right? If I needed to scale up, if I needed more resources for my application, that was it. I had to have another copy of my server. So for me, that meant I maybe had some stuff in EC2 user data. It would provision a new host when I came on. But ultimately, if anything needed more capacity, I had to scale up a whole nother server. But we don't have to do that anymore. Now, if I need more capacity, my service just scales up. So maybe I run a couple more copies of a single task. So I'm using my resources a little bit more effectively, but it also lets me do things more fluidly as well. So I can scale in response to something else rather than just saying, well, I need some more of this little section, so turn the whole thing up. Container, bottom line, lots of options for running your workloads. And everyone was always going to say that this is a cop-out answer, and it's not, I swear. But ultimately, you have to use what's right for you. So if I use ECS and someone else uses Kubernetes, they're all good choices. You do what you think you can scale. You do what you can maintain. So a lot of people, they're like, well, which one should I pick? And honestly, it depends on what you're doing. So focus on what the job of what your application is. So focus on what you're trying to do, focus on what your team can do, focus on what your team is good at, and then let your infrastructure choices follow that. So pick what supports your use case, and not maybe what everyone else is doing. So why do you want options? So why do we have a couple? Why are there lots more out there? Why does everyone kind of use a different thing? Options are good. They make the community a lot stronger. So there's really rich and part of this is it's a good position for those of us working with containers to be in, right? Because there's a very rich ecosystem around containers right now. So you see lots of people making tooling, you see lots of people writing about their infrastructure, you see lots of people blogging and speaking about it at conferences. So we're in a really good position, right? Where you can see there's tons of people working on it and sharing their experiences and telling everyone what they're doing. And if I'm working on a problem, chances are that one of you is working on the same problem also. So by having lots of options, it makes the community stronger in general. And the VPN. Oh my God. It doesn't even show up on the screen, I don't think, but like every 2 minutes there's a little pop-up that says, do you know that you're not on the VPN? Do you know? And I did know, but it won't stop popping up. And I think something that's not talked about as much as it should be is you don't have to pick just one. So I think part of the thing, I feel like at this point I'm like a single Fargate feature evangelist, but you can run hybrid clusters. So if you have some tasks that you can kind of go hands off on, run them in Fargate mode. But if you have something that you still need to make changes to your underlying cluster infrastructure, run it in EC2 mode. And you can have them in the same cluster. So part of the great thing about working with containers is that you don't have to pick just one. You don't have to pick one language. You don't have to pick one tool. You don't have to pick one anything. You can use what works for you. So that might mean that I write half of my services in Ruby and half of them in Python, and then I still have some bash going on in user data because everyone secretly still has bash doing everything. And if you tell me you have none, I don't believe you. You don't have to choose, though. You don't have to pick. You don't have to limit yourself to something. You can try new things. Part of what's great about containers is that it lets you have polyglot architectures like this. It doesn't make you kind of pick one road and only go down it. So try out different things, run hybrid clusters, write different languages, use different tools. And it's about the tool that works for you and not the tool that works for the guy sitting next to you or the person that sits across from you at work. You can use all of them, you can use some of them, you can use none of them. And ultimately, the point in AWS is that we just want it to be a good place for you to run your container workloads. So it shouldn't matter what orchestration system you use or what language you use. We just want it to be the best place. So what does a landscape look like when you look at all the pictures together? So pretty logos. Amazon ECS, available now. Amazon EKS, it is in preview right now. I would say that it is a limited preview because a lot of people are on the list for the preview. So it is in preview. People have been pretty slowly getting access to it. So if you're on the preview list for EKS, please stay tuned. Fargate mode for ECS is out right now. So you can create things. You can create and run containers in Fargate mode right now. And then Fargate mode for EKS will follow a little bit later we're in 2018 now, but sometime other than right now in 2018. So let's compare a little bit. So a lot of these ultimately, by the way, are going to be really similar. So there's some things that we want to be a part of kind of anything, right? So we probably wouldn't make EKS have no AWS integration. So a lot of these things will be kind of the same. But we'll just look at a really high level at the differences between a couple of these, and then we'll talk about how you can go about choosing between them. So first one, ECS, this is probably the most familiar. I think what's more important here is what's new in 2017. So these are a couple of them. I think a couple of themes. So in general at AWS, we base a lot of what comes out for features based on customer feedback. And a lot of feedback was, I want to support other Docker options that maybe aren't in the dropdown for ECS. So I see a lot of those. So privilege mode, supporting other device flags. So what people are looking for, and I think, so this is something to kind of look at a high level for whatever orchestration platform you're using. But I kind of see, I want two things from my platform. I want the ability to customize what I want, which is a what I want situation. But I also want sensible defaults. So if, for example, I am not a networking expert, I should have a sensible default for the networking options. So if I'm not an expert on something, I should be able to trust that the platform that I've chosen has something sensible for me to fall back on. So if I'm just kind of spinning up a service and playing with it, I shouldn't have to do a bunch of. It would be really great if I had a suggestion from the platform on here's some good resource usage limits. Maybe they're not perfect for your use case because no one knows what your use case is but you. But here are some pretty sensible ones that you could use as a starting point. So that's what I'm looking for. I'm looking for a sensible starting point. So if I didn't choose to tune anything myself, what's kind of the fastest way that I could get started and know that something would work pretty well? And then the second one is I want to customize on top of that. So if I am an expert, so if I'm a networking expert, or if I know that I need something changed on the instance level, or if I know that I need this particular flag, I want to know that I can support that too. So a bunch of extra support here for things like extra flags or extra Docker flags, different load balancer supports. So first it was just ELB Classic, and then the last year or so, application load balancer, network load balancer. I'm not sure if we'll go into the details between the different load balancers today, but quick one, application load balancer lets you go at the application layer. Really great for microservices because it lets you do path-based routing. So if you use CloudFront, it's actually a really similar kind of pattern matching behavior. So if I have a path that ends in /web, go to service A. If I have a path that ends in /API, go to service B. So it lets you do path-based routing. I will talk probably to the point of exhaustion about resources later. And one of the good things for me from the application load balancer was that it removed one of my resource constraints. So formerly, the big ones were memory, port, and CPU. So if I have a service that runs in 8081, I'm kind of stuck. I only have one port 8081. I cannot magically make a second port 8081. It's a hard limit. So I need to if I need another 8081, I need another service. I feel like that's kind of like an old-fashioned monolith limit, right? Because I shouldn't have to have a whole new server to run another copy of my service. So application load balancer does dynamic port mapping, so I can pass it as 0 as my host port, and then the load balancer will take care of registering it to a port when my service scales up. So application load balancer, network load balancer, obviously at the network load level. You can tell the engineers name these because you just name them for the level that they were working at. So apparently other people aren't creative with naming also. So a couple different options there, and people were finding that there was different options for load balancers that maybe worked better for their container workloads, for their microservices. So network load balancers in particular, really good for kind of funky traffic patterns. So if you're going to go way up and then way down, so very like erratic spikes, network load balancers are really high performance, but they're also really good at kind of spiky, erratic traffic like that. So supported different options, added some new flags, support for Windows containers, support for HIPAA eligibility, Spot Fleet, cron, 2 different regions, Seoul and Beijing. So more important probably than what we started with ECS is what happened in 2017. So still adding new things all the time. EKS, so there is a deep dive on the VPN. There is a deep dive on EKS, by the way. So if you're on Kubernetes and AWS, and I think he'll talk a little bit about EKS. If he wasn't planning on it, Paul, I'm sorry. Now I guess maybe you are. So EKS, managed Kubernetes. The way that it works right now, just in case I ruined it for Paul and he wasn't planning on talking about it, you can basically speak to your cluster via the kubectl. And I'm not going to argue with anyone on whether it's kubectl, kubectl, kubecontrol. The guy that started it said it's kubectl. So it's the new GIF versus GIF. So basically, EKS in the managed AWS fashion, Fargate, kind of like containers on demand, but mostly underlying technology powers. How do you just manage the container piece without any of the underlying infrastructure? TLDR, which is not in fact too short. But some similarities here. Ultimately, all 3 of these are going to be managed. So how can I get some help from AWS on some of the heavy lifting for things like resource usage or networking? I think the biggest thing to point out here for Fargate is because I have a lot of people that say, how can I exec into a container on Fargate? You can't. So now it's recorded, so now everyone knows. You can't. So if you still have a use case where you're looking to exec into the running container, or if you're looking to, and the slides will be posted, by the way, for those of you taking pictures of them, they'll go out online. So there's an easier way to live your life in between now and then. So you won't be able to control the underlying cluster infrastructure, obviously, because it's managed for you. But you can run hybrid clusters. So right now, if you're looking to exec into a container on Fargate, it's the same kind of task definition, so I would just restart it as type EC2. But obviously, you give up some things in exchange for a managed service, so you can't manage the things that someone else is managing. So more info on how to choose. So one of my colleagues wrote a Medium post on this, which I linked to because I will post the slides, on how to look at the differences between the different container environments. So I included a link to it, so feel free to read at your leisure. Ultimately, though, the same answer as always, which is pick the tool that works well for you. So use whatever you can support, use what you're comfortable with, use what you can manage. If there's a feature that you want in ECS, use ECS. If there's a feature that you want in Kubernetes, use Kubernetes or EKS. I'm actually probably the most excited about Fargate because so I ran containers in production for a while, and I would love to not manage them. That sounds great. I think the best orchestration tool is one that I'm not doing. And there's really powerful things that come from the orchestration tools, but I think ultimately what drew me to using containers in the first place was that they supported what I wanted to do better, that I could scale them better, I could get them out faster, so I was a DevOps engineer, and it led to a kind of a better sense of people being involved through the whole pipeline. So Amazon is very big in if you build it, you run it. And I think containers lend themselves really well to that. So I can be responsible for a service from developing locally to testing in a staging environment to deploying to a production environment. I can be responsible for that the whole way. And there's a lot less of the whole, well, now it's DevOps' problem, or now it's the developer's problem. And there's a lot less of passing the buck back and forth. It's the VPN again. Just letting you know it is still there. There you go. So I think it was more about what I could support with the containers and less about the tools that I was using to run them. People are obviously very opinionated about their tools. But what draws me to Fargate is the idea that not only can I make those containers and those tasks the new kind of primitive, so I can focus on kind of the unit of work that I'm doing. So if I'm working at the container level, I shouldn't have to think about running infrastructure to run my container. I just want to worry about the container itself, which is what I care about. So what are people building with containers in AWS? And the short answer is kind of everything. So I think what people are finding is that although it's a popular way to build things right now, you can really do anything. That it's not about the containers, it just works really well for a lot of use cases. So everyone, and these are a mix of ECS and Kubernetes customers, by the way. So they're not all ECS or they're not all Kubernetes, but people in kind of pretty much every type of business and every type of use case are using containers now. So it's everything, but it's also what you guys are building too. So that's why you're here for the containers track, is you're either using them or you're interested in using about them, or you wanted to make fun of me on Twitter, or you're a big fan of Paul. It really could be anything. So what's next? So first up is today. So here are the remaining sessions for this track. So first up, I actually think we have a break already after this. So first up is at 10:30. So after the break is the deep dive on ECS. That's with Paul. Then we have Kubernetes and AWS, which is at 11:30. So right after that is also Paul. So ECS, and this will just be, I believe, regular Kubernetes and AWS with possibly a guest mention of EKS. Then we have lunch, which is important. Then we have deep dive on Fargate. So that's with me this afternoon. And then we have the final session in here is going to be advanced container management and scheduling. And that is a really boring name, but I made it myself, which is why it's so boring. And we're going to be talking about a lot of it will be ECS specific, but it will be a lot about how to do task placement policies and strategies, how to pick resource limits, how people are tuning their resources, and then we'll look at some of the actual API calls. So when you start up or register a new task, how are resources requested and allocated? So that's probably the most technical one. So all of these will have, everything but this talk that we're in right now has demos. So these will all have demos or code samples. And then the last one will be a lot of information on resource usage. Yes, that's Paul.
We're just going to talk about generic Kubernetes too.
Okay.
We're just going to dive deep on EKS and get hands-on and build stuff, like the service. So.
Paul wants to build stuff today instead of talking, so we're just going to build stuff in Kubernetes, which actually sounds more fun. So change of plans, but a good change of plans. So that's it. Obviously other tracks running today too, but that's the plan in here. And so the person that just spoke is the guy giving the next two sessions. So if you have any questions, Paul's also happy to answer your questions after this. So how can I get started other than today? So the best time to get started is today, because we're here and it is beautiful and it'll be great. So how can you get started? So I included a couple links. Once again, I will post the slides. So if you're taking a picture of the slide, you don't have to. A couple links. EKS preview page. So Fargate in particular, I think the best place to start, and I will never make this recommendation again for anything else, but the best place to start, even if you are not new to containers, is the Getting Started wizard. I had to have someone tell me about that because I was like, well, I'm not just getting started. Why do I need a wizard? But the wizard is actually delightful, and they put it looks like they worked very hard on making it's a new concept for all of us, whether we're new to containers or not. So I actually found the wizard very helpful in explaining what things I needed to manage with Fargate and which things I no longer needed to manage. So do not be put off by the getting started wizard section, because it is actually great. If you go to your ECS console, so I'll show it later in the Fargate deep dive, but if you go to your ECS console, there's a blue, everyone knows like the blue AWS new announcement banners. There's one for Fargate, and there's a link that says like learn more, getting started. Click on it, I promise. It's actually a much cooler wizard than I expected. I included a couple of blogs too. So Liz Rice works at Aqua Security, and she put out a cool blog post. She did a little test application. They obviously do security, but she did a small application on Fargate right about when it first came out. That's an interesting one to read if you're looking for someone that actually ran and built something on Fargate. I have a couple in there from Nathan Peck. The Choosing Your Own Container Environment is one of them. He's one of the ECS developer advocates, I guess now a containers developer advocate. So he does a bunch of writing on how to choose, a bunch of reference architectures, a bunch of stuff like that. So good resource if you're looking for one. And then I also included a link to the official State of the Union. So this is obviously not the final container State of the Union for 2018. There will be more of them. So I included a link to the reInvent one. So that's with Deepak Singh, who's the GM of containers here. So that one's worth a look if you're looking for the longer official version. And then to answer kind of a very common question, which is, I'm building something cool and I want to tell you about it, or I want to talk to other people that are building with the same tools, or I want to talk to someone from AWS. We have 2 Slack channels that members of containers teams hang out in, and also a lot of the community members hang out in. So those are 2. Or there's a lot of AWS evangelists and developer advocates that hang out places like Twitter. This is also my email address. So if you have a question, I've been soliciting feedback a lot recently on some of the container stuff. So if you have feedback or a comment or a question, there are lots of people that are happy to talk to you about them. So I'm obviously happy to talk in person right now or later today. But you can also tweet or email us or DM us to ask questions or say, hey, I'm not sure this looks right. Everyone's very friendly and they're very happy to talk. So those are some Twitter handles of people that will probably help, and also my email. I didn't include other people's emails because I thought maybe I should tell them first. But mostly you should go build, and then you should also tell us about it. So build cool stuff, learn cool stuff, write blog posts, tweet about it, but then also let us know, because I think one of the coolest things about working here has been that I'm finding people more and more likely to share what they're working on. So why I started talking about things for what I was building from the customer perspective was that I didn't see anyone else talking about it. And I said, well, I think what I'm working on is obviously special, Snowflake, amazing, but it's not. Lots of people are working on it. And if I'm having that problem, I'm sure that someone else is having that same problem. Or if I found this really cool workaround to something, I'm sure other people would also benefit from that same workaround. So go build cool stuff, tell us about it, and also tell everyone else about it, because we're not working on unique problems in a lot of cases, unless you're doing something crazy with machine learning, in which case definitely go tell Julian Simon, because I'm sure he'll put it on YouTube. But go build cool stuff, tell us about it, but also don't build it in a vacuum. So if you're working on something cool or you found a really awesome way to do something, let everyone else know, and then use your community as a resource as well. I will take questions now if you don't mind being on the recording. So it's still recorded, by the way. If you do not want your question recorded for some reason, or if you're camera shy, after the recording, I will still stand here and answer questions, but not on the recording. So does anyone have a question that they don't mind asking? That is what I thought. So we will wrap up the official part here. You have about We have 15 minutes for questions here, and then it's a break. So I will stand here. Maybe Paul will join me if he's feeling generous. We will answer questions now, then it's break time, and then we either see you guys back here right after the break or enjoy the rest of your sessions. Thank you.